Alright, we'll begin this with an intro into energy in case you've been paying, zero attention over the past week or so. First thing we need to know is that energy, just like momentum, is conserved. So energy initial equals energy final. Alright? That's the first thing. The other thing is we have three types of energy. We have gravitational potential energy. This is energy based upon height, and it's equal to mass times gravity, the acceleration due to gravity, times height. So mass times 10 times height. Then we have kinetic energy. Kinetic energy is the energy of movement, and this is equal to 1/2 mv squared. So anytime anything's moving, it's equal to 1/2 mv squared. Number 30, the third type, is elastic potential energy, and that's equal to 1/2 kx squared, where k is the distance a spring is from normal. So if this is the normal length of the spring, x would be, if I stretched it, this length here, and if I compressed it, this length here, right? It's the difference from normal. So you can have it either way. You can either pull the string out in a stretch, or you can compress it in a compression. So those are the three types of energy. The other thing we need to know is there's energy loss. We can lose energy. We can lose energy to various things. We can lose energy to friction, to heat, to work. All right, lots of things we can lose energy to. All right, so there's these types of energies are conserved, but we also have energy loss that we can have happen due to heat, friction, or work being done. All right, the next thing we need to know is power, and rather, I guess we should start with work, because work is part of power. So work is equal to force times the change in displacement. So if you're trying to figure out what work is, you take the force of the force that you're pushing or putting on the object, and you multiply it by the displacement. So you shouldn't end up with something like 20 newtons times 5 meters. And the unit for this, when we get it, is 100, and the unit is joules, because work is a form of changing energy, and so therefore it's got the same unit as as energy, which is a joule. One thing to be careful with is sometimes it will give you the weight of an object. The weight of an object is its force of gravity, so it should already be in newtons. So if you're lifting a 20 newton, if you lift an object that weighs 20 newtons is the force that you're going to plug in there. All right. Now there are exceptions to this, and they should be obvious when you see them. But if you're lifting a 20 newton object, and that's all you're doing is lifting it, and ask you how much work you're doing, well, that's how you would calculate it. All right. So that's work. Then we have power. Power is equal to work divided by time, and this is how efficiently we can do work. Power is measured in watts. It's basically a measure of how fast can you do the work. So if you wanted to climb up the stairs, the faster you can climb up the stairs, the more power you're going to get out of it. It is not about how much effort you put in. It's about how quickly you can do the work that's being required of you. All right. So that's a brief overview of what we've talked about so far. So I shall do some review problems now.